Hi, everybody. Thanks for joining us here at the Apps on Cloud Summit. My name is Rick Ochs. I'm the Principal Product Manager here at Turbonomic over our cloud capability. Today, we're going to show you a little bit about how to do cloud optimization on storage, not just optimization, but application performance management when storage comes into play, specifically on cloud resources. So first, we're taking a look at one of our environments pointed at some cloud resources. And you're going to necessarily see right off the top, we have our supply chain stitched here all the way down through the infrastructure, VM, and volume. So we're going to take a look at a few of these actions and describe what they do and how they work. So here we can see a list of volumes in a cloud environment. We can immediately see if there is an action on these, whether there's performance issues or whether there's unneeded cost. And we can also take a look at if these actions require disruption to take them, whether the VM needs to be rebooted for a scale action to occur. Now, there's a lot of changes that happen on volumes. Typically, you'll see 3 to 4 times the number of volumes than you do VMs. So this is an environment that's largely unmanaged in the cloud. Typically, policy is set on standards for GP2, GP3, or premium storage tiers, those sorts of things in public cloud, and that's just sort of set and forget unless there's performance issues. Turbonomic's approach is to manage this actively, to size and scale things for performance. And that way we can do so without spending massive amounts of money that may not be necessary because the applications are always well performing. So for some examples, I'll dive into a couple of these actions here. I just picked one here that has no downtime, which essentially means we can take this action without a VM rebooting or without any disruption to the service on the VM. We like to look at these ones first because they're the easiest to execute without needing change windows or downtime windows, things like that. So here we look at a standard volume in AWS, and the recommendation is to go to GP3. You'll notice it tracks how many build IO requests it has. It tracks the IOPS utilization, the throughput utilization, the disk size, and all of the cost information associated with the current tier and the destination tier as well. Now, the scaling engine, just like all of our scaling engines, is focused in on performance specifically. So you're going to see what we call our 95th percentile marker, which is what is this workload doing 95% of the time, essentially. So here we can see we have very high IOPS utilization. This poor disk is being crushed. It's getting no help. It has 160 IOPS and it's being utilized a hefty amount of the time. And so we have a scale action to go to GP3. Now, what's really cool about this is that GP3, the new tier that AWS released, is much cheaper per gig. So we're actually reducing the spend while increasing, you'll see that at the top right over here, while increasing the IOPS capacity. You can see this scale action goes from 160 IOPS here to 3,000 IOPS. The disk size remains the same and the storage cost plummets by almost all of the cost of this volume. So that's an example of a storage scale action. There are others. I'll grab one on Azure specifically so we can kind of compare what that looks like between cloud providers. Let me expand this out and grab a managed premium. So here is a Azure managed premium disk. We can see it's being recommended to go from premium SSD to standard HDD. We can clearly tell right when we open this action why, because nothing is happening here. This is dead as a doornail. And it's got 5,000 IOPS associated with this volume. It is being used 95% of the time, less than 1%. So utilization is in the basement. We also have a similar utilization rate for throughput. Now that's important because sometimes we see workloads that have huge throughput needs and low IOPS, or vice versa. You might have high IOPS needs and low throughput. Sometimes SSDs are a better fit for that, or for high throughput workloads, spinning disks can be a better fit for that at a much cheaper cost. So there's ways to protect the application's performance needs without hemorrhaging money, right? And so these are the benefits of keeping these applications extremely healthy without having to go in and manage and maintain the volumes at a very costly style. Now on Azure, there is downtime to execute most storage scaling actions except for ultra storage, which does not take downtime to scale. So just be aware of that. If you are using ultra storage, we can scale that with no additional downtime, and it can be very successful because you can scale IOPS and throughput independently of each other, which is very powerful. So those are some of our scale actions. Note, we also have scale actions dedicated to just performance actions. These ones are much more popular to automate. So we can automate away performance issues very quickly and easily. With and without disruption, you can schedule them in maintenance windows or downtime windows pretty easily as well. So here's an example of something that would increase its storage size to therefore increase its IOPS capacity. That's a little trick that Turbo sometimes does when it is a cheaper solution to a performance problem to size a volume up than it would be to switch to a much more expensive tier. So we can solve these performance issues in a very educated way. So that's it. Thanks for watching. I appreciate your attention, and please reach out if you'd like a further demo or information on how our storage scaling works. Additionally, check out our blog posts on storage scaling and cloud. We've got some really fantastic engineers that have taken the time to write up a pretty lengthy analysis about how storage scaling works in public cloud. Thank you very much.